So waves and oscillations we will do today. Okay. So theoretical thing, so no problems in this session, but conceptual wise, I'll make sure that everything is very clear to you. There won't be any doubts, that I can promise. Okay, so I'm just switching off the video because I'm writing it on the board. That's the reason. After that, I will come on to the video. Fine. Anything is there, please put a chat. So waves and oscillations, the first important topic in this is periodic oscillation or periodic motion. Instead of going to periodic oscillation, we'll go to periodic motion first. Correct. So the first thing which will come to our mind is the simple pendulum in this. So we will be discussing this in detail, the simple pendulum. Okay. Then comes what? Oscillatory motion. Correct. This is nothing but periodic motion, is the motion of a simple pendulum. But what about my oscillatory motion? If it is my oscillatory motion, there also I can write what? Simple pendulum. I can write the same example, simple pendulum. Correct. Or else I can write what? Loaded spring. So two things I can write: motion of a loaded spring, motion of a simple pendulum. So I'm getting something in chat. Yes. To and fro motion. Correct. Oscillatory. Now coming to the harmonic oscillation. Okay. Fine. So what we should, before going to harmonic, what we should understand is oscillatory motion and periodic motion. So I written here simple pendulum. Correct. Now one very important thing here is every oscillatory motion. Which one? Every oscillatory motion is what? A periodic motion. But every periodic motion is not what? Oscillatory motion. Okay, so that we have to understand, because in entrance, correct, in entrance especially, they'll try to confuse us. They may give some examples and tell us which is false or which is true. So that we have to do it. So what I was just telling is, this is for the guys who just joined now. So I was just starting about the waves and oscillation chapter in physics class 11. So periodic motion. There are mainly three types of motion: periodic motion, oscillatory motion, and harmonic motion respectively. Periodic motion, I can take simple pendulum example. Harmonic oscillatory motion, I can take what? Simple pendulum, loaded spring. Two things are there in this. So what I was telling is, in every oscillatory motion is a periodic motion, but every periodic motion is not a oscillatory motion. That's all. Okay. Now coming to this, you got something called third one, harmonic oscillation. So in your higher classes, that is especially if you're joining engineering, you'll get something called sin HT, cos HT and all. Okay, sin HT will be there, cos HT is there. H stands for hyperbolic. H stands for what? Hyperbolic function. Okay. Please erase this 1 second. Not hyperbolic, it's hyperbolic function. So we should understand what is this thing. Okay. So what is this hyperbolic function? What is this harmonic oscillation thing? But the oscillation which is expressed in what? Sine or cosine function. If you want to know what is function, it is f of x. F of x is my function. F of x is my function. And this is expressed as what? Sine. Correct? Sine x. That is a function. If f of x is equal to sine x, differentiation we all know. F dash of x, in the sense single differentiation. That is nothing but what? Cos x. F of x is sin x, f dash of x is cos x. Correct? So now this is what? This is a harmonic oscillation. In the sense harmonic oscillations are expressed in terms of what? Sine and cos respectively. I'll write down here. Harmonic oscillations are those oscillations which are expressed in terms of what? In terms of sine and cos respectively. For example, in this chapter, we can see something called sine omega t, cos omega t, sine ht, okay, cos ht, all of these things. Fine. So these are my three types of oscillation. Now coming to my motion. Okay. A very important thing is my SHM. This is a very easy concept to understand also. Simple harmonic motion. In the sense, first thing which will come to my mind is what? A simple pendulum. SHM is nothing but simple harmonic motion. This is nothing but what? My simple pendulum respectively. So what is this thing? Correct. So we can see that, for example, I'll draw here one line. Correct. I'll draw some more lines here. Now the pendulum is being what? It's being what? Oscillating, right? Like this, it will be oscillating. So what will happen is always it comes to the mean position. Correct. It is always acting towards the mean. What is acting? The displacement. Correct. The displacement is always acting towards what? The mean position. In the sense, correct, first thing is it is having a constant height, amplitude. This doesn't change. This is same for the same. This doesn't change. Correct. It is having a constant amplitude. Correct. And one more thing is it is only having one frequency. It is a single frequency. So important point here to note is it is having, first one is what? Constant amplitude. That is height. Amplitude in the sense height. Constant amplitude. And second one is what? Single frequency. All of these things are very important. Okay, fine. And the magnitude of displacement. The magnitude of displacement, if even if it is going like this, then coming like this, it's always towards what? Mean position. In the sense, the magnitude of displacement, I'll write here third point. The magnitude of displacement is always towards the mean position. Okay, so if I am combining these three things, I'll get a definition of simple harmonic motion respectively. Okay, simple harmonic motion respectively. So if you ask me, okay, so can you just tell me what is the difference between simple harmonic motion and oscillation? So just now we discussed sine omega t, cos omega t, right? So if you ask me the SHM here, I'm just writing the SHM here, correct? Yes, all of this thing can be a simple harmonic motion, sine omega t, cos omega t, whatever it is. So I can write here f of x. I think we all know what is f of x. F of x is nothing but y. I'm just putting as variable y. This can be what? Sine omega t. This is a function, that's it. So whenever you see these things, sine or cos, kindly do not get worried. This is nothing but a function. What is function? Just like a plus b, operation, right? That's it. It's an operation. Obviously, a function is nothing but it will perform that job. That's it. Correct. It will perform that job either daily or weekly, keeping an alarm clock. Okay, it can be a daily, it can be what, weekly once. Correct. Every Monday at 6 a.m. So same like that. Function is nothing but it's a periodic thing. It will repeat. Correct. Every year we'll have a new year, right? January 1st. So that is something which is repeating all the things. This is only function. If you just can take to the real life or real world thing, it's much easier for us to relate. So that's more important for us. So just going to write y is equal to sine omega t. So you may ask me, where is the amplitude in this? I told you what constant amplitude or constant height. So I can just put what? I can put a variable here. Y is equal to a sine omega t. I can put y is equal to a sine omega t. Where a is what? Where, what is my a? My a is the amplitude here. That's all. Okay, correct. Sine omega t is my function, main function. That's it. Again, amplitude of what? Amplitude of oscillation, because obviously we are discussing about the chapter oscillations and waves here. Okay. Now one more thing. It's again theory. Since I just discussed about SHM, I should tell you what is non-harmonic oscillation also. Non-harmonic oscillations. Okay. So in non-harmonic oscillation, the same thing. Okay. I'll write out an mathematical thing only. Y is equal to, let me take a sine omega t plus b sine ht. I don't want to make it much complex. I'll write in words. Y is equal to 2 sine 50 plus 3 sine 40. Now I want to know from each and every one of you why this equation is not a non-harmonic oscillation. From each and every one, I need the answer. Please send me in chat option. Whatever you feel like. So Matyesh has asked me one question. Could you please repeat the oscillatory motion? See, oscillatory motion is something but what? To and fro or back and forth, right? About a fixed point. What is non-harmonic? That's what I'm telling you. Why this function is non-harmonic? That is my question, Athar. You should not ask me that. My question is, why is this function non-harmonic? That is my question to you. If you understand what is harmonic, Rishabh is very correct. Nikita is correct. Yes. Let me see. What's non-harmonic? Otherwise, ask me. Sumedha, correct? Yeah, very good, Sumedha. First person to answer. Correct, Samanyu. Adish, angles are not equal. Good. Atar, from you, let me shoot out the answer, Atar. Whatever you feel like. Don't be blank. Ria, what is not equal, you should tell me. Yeah. Arya, very good. I'm not telling the answers now. Where is, it's because of two variables. Other, uh, what two variables you're telling? Akarsh, the angles are not equal. Correct. The quantities are not equal. A and B. What is this A and B thing? I'm talking about this equation, the pink color one. The pink color one, you tell me, that's enough. What is this A and B? Where is Emmanuel? Vanshika? Yeah. Vanshika has given me the answer. Okay. Okay, Vanshika. I don't know. I don't like that answer. Any other answer you can give me? Whatever you feel like. My question is simple thing. Why this is non-harmonic oscillation? We just now learned harmonic oscillation. Why this is non-harmonic oscillation? So guys, first thing we to understand in this is very important. If we understand, I think one chat option is coming. Yes, Other, you are correct. So Other, you can answer. La. So anyway, coming to this, what is the first point I told? Constant amplitude. I explained you clearly what is the constant amplitude. This is my amplitude here. Correct? Constant amplitude. Now here in this particular thing, I can see A and B. I given value of A as 2, B as 3. Correct? Is the amplitude same? Is the amplitude same? I'll circle out the amplitudes. 2 and 3 are my amplitudes. 2 and 3 are automatically what? Different. Correct? If it is different, then what is it? It is not what? A harmonic oscillation. It's not a harmonic oscillation. That's what is important for us. So mathematically, we have to know the difference. It's not about learning the definitions alone. That we cannot do anything. Correct? We have to know what? We have to know mathematically what is there correctly. Yes. So what is this? This is a combination of two harmonic oscillation. So what is a non-harmonic oscillation? We can now write in words, because if I take max as 4 quadrants, numbers, words, variable, diagrams. This is variables are represented. Words, if I want to tell, how do I tell it in words, this thing? Correct? So it's a combination of two or more than two harmonic oscillation. So this is a combination of what? Two or. This is a two harmonic oscillation, correct? So non-harmonic oscillation, nothing but what? It's a combination of two or more than two harmonic oscillation. That's it. But main thing what we have to get gain from here is what? Amplitude is different. And one more thing, angles. That also you can tell, correct? Yes. But main thing here is amplitude. Even if I write the angle same, sine 50, we won't get the correct answer. 1 second, guys. I'm just getting a call. So one of the most important thing which will be asked in your examination, especially the entrance, but angular frequency. Correct? Yes. Angular frequency in the sense, first thing is that I'll draw a circle here. I'll just draw a line. Okay, it does what? It does the complete revolution. 2 pi. Correct? The frequency which does the complete revolution of a circle. That is nothing but what? Our angular frequency. In the sense, up to this 90 degree, then from here to here, pi. Correct? 270, then 360. That is 2 pi. From 0 to 2 pi. So, how do you learn this? Angular frequency omega is nothing but what? 2 pi and what? F. And F is what? 1 by T. So, Homer has showed me the answer is 2 pi into 1 by T. That is also correct. 2 pi by T. That is my angular frequency. So, because we already know what is frequency, 1 by time period. In a lot of entrance examination, they can ask this thing, 1 by T. Okay. So these are the important things. Yeah, 2 pi F. Samanyu. Everyone has told the correct answer on this. Yeah. Angular frequency and angular velocity. So angular velocity, I'm giving V. Okay, just a vector thing. 2I plus 3J plus 4K. Okay. So if I want to find angular frequency from this, I'm just giving F. There is nothing but root of square of 2 square plus 3 square plus 4 square. So we can say that angular frequency is nothing but what? Magnitude of angular velocity. Okay, angular frequency is nothing but what? Magnitude. That is the root of square of these terms. 2 and 3 and 4. So this is one more learning for you guys. I just want to tell you the last thing which I told now. See, angular frequency and angular velocity relationship. If the velocity vector is 2I plus 3J plus 4K, then what is my frequency? The magnitude of angular velocity. In the sense, the root of square of these values. That's it. Root of square of these values. That's it. Clear? The relation is nothing but what? What is the relationship? I think now it's clear, right, Matesh? Yes. So angular frequency is the magnitude of what? The vector quantity, angular velocity. That's it. Yeah. So I'll just end the meeting now and I'll be sending you one more mail.